This is a graphical analysis type question, also a function defined as an integral type question. So with a function defined as an integral type question, one of the first things we should do is set up the relationships between g and f and their derivatives. This is also a non-calculator question. So g of x is equal to the integral of f from 1 to x. What that means is that g prime of x, taking the derivative of an integral where the upper limit's a function of x, I'm going to plug the upper limit into the integrand times the derivative of the upper limit. So g prime is equal to f. G double prime is equal to f prime. And the graph that's given is the graph of f. So what I'm looking at is the graph of f, which is also g prime. And then question A asks to find the value of g of 2. So then looking for g of 2 is going to be plugging 2 in for all the x's, the integral from 1 to 2 for f of t dt. And we're going to sum up the signed areas from 1 to 2 to find the value of that integral. So the integral from 1 to 2 is going to be this area. So it's going to be a triangle. 1/2 base times height. It's going to be negative because it's area below the curve. The base is going to be 1. The height, I'm going from 0 to -1 as x moves from 1 to 3. So then the y value at 2 must be -1/2. No need to simplify since this is free response. So then moving on to the next part of A, which is finding g of -2. And again, plugging in for all the x's, and this is going to be the integral from 1 to -2 of f of t dt. And what I want to notice is that the smaller number is the upper limit. So then flipping those limits, multiplying by a negative, gives me the integral from 1 to 2 for f of t dt. And then finding the area then from -2 to 1 is going to be this triangle above the x-axis and then this semicircle. So the negative of the sum of those signed areas. So 1/2 base times height for the triangle, and then 1/2 pi r squared for the semicircle. The base of that triangle is 1. The height of that triangle is 3. The radius of that semicircle is 1, and this is not a plus, it's actually a minus. That semicircle is below the x-axis. And again, no need to simplify, so then that's g of 2, then moving on to part B. Part B says find g prime of -3 and g double prime of -3. G prime of -3, g prime is equal to f. So g prime of -3 is f of -3. Reading that value from the graph, as x moves from -4 to -2, the y moves from 1 to 3. So at x equals -3, the y value must be 2. And then g double prime of -3. G double prime is f prime. Makes this problem easy because we set up those relationships at the beginning of this problem. So what I want is f prime of -3. I want the slope of f at x equals -3. We can do change in y over change in x. So 1 minus 3 over -4 minus -2. No need to simplify. So we could leave the answer like that. The slope turns out to be 1. So. But again, no need to simplify since this is free response. Part C says find the x-coordinate of each point at which the graph of g has a horizontal tangent. So then moving on to part C. In order for g to have a horizontal tangent, g prime, which is f, must be 0. The slope of that horizontal tangent for g is 0. So then we're looking for all the places on this graph where f is equal to 0. That happens in two different places, at x equals -1 and x equals +1. So G has a horizontal tangent at x equals -1 and +1. Then it says for each of these points determine whether G has a relative min, relative max, or neither. For a relative min for G would have to change from decreasing to increasing, which means G prime, which is f, has to change from negative to positive. In order for G to have a relative max, G would have to change from increasing to decreasing, which again means G prime, which is f, has to change from positive to negative. And so looking at x equals -1, at x equals -1, this graph changes from positive values to negative values. So G prime changes from positive to negative, which means at -1 there is a relative max. So G has a relative max at x equals -1 because G prime, which equals f, changes from positive to negative. Then looking at x equals +1, at x equals +1, the values don't change signs. The values are negative to the left of x equals 1 and negative to the right of x equals 1. So then G has neither a relative max nor a relative min. At x equals 1 because G prime, which is f, does not change signs. Part D asks for all the values of x for which the graph of G has a point of inflection. This is part C. Part D. A point of inflection for G means where G changes concavity, either from up to down or down to up, which means G double prime would be changing signs, either from positive to negative or negative to positive. And what that means for G prime is that G prime would be changing from increasing to decreasing or decreasing to increasing. G prime, which is f. Since I'm looking at the graph of f, these are the characteristics that I'm going to look for. Looking at the graph of f, here is one place where I'm changing from increasing to decreasing. Here's another place where I'm changing from decreasing to increasing. And one more place where I'm changing from increasing to decreasing. So 3 points of inflection. X equals -2, x equals 0, x equals 1. G has a point of inflection at x equals -2, 0, and 1 because G prime, which is f, changes from increasing to decreasing. Or decreasing to increasing.